This is the first in a series of videos on isosceles triangles. And to start with, let's go over some vocabulary. So let's take a given triangle and let's label it A, B, and C. So the first thing we want to talk about is what an angle bisector is. And if you think about an angle bisector, what a bisector does is cut something in half. So an angle bisector would cut an angle into two equal parts. So if we think about a line here such that this angle and this angle are equal, then we call that an angle bisector. The other vocabulary that we need to think about is we need to think about side opposite and angle opposite. So let's think about side opposite. We talk about the side opposite of an angle. In this case, if we think about, to just pick an angle, let's take angle A. The side opposite is simply defined as the side opposite, easy enough. So in this case, the side opposite of angle A is going to be BC, or you could say CB. If you think about the angle opposite, it's just the same idea, right? Given a side, let's take a side. If you take a side, say let's say AB. Take a side AB. If we think about the angle opposite would be angle C. That helps us in our definitions. So let's define what an isosceles triangle is. We say that an isosceles triangle has two equal sides or more. The reason we say more is that the theorems that go along with isosceles triangles also go along with equilateral triangles. Equal sides or congruent. And then when we have an isosceles triangle, we have certain vocabulary that go along with it. So let's think of an isosceles triangle where this side and this side are equal. Then we have what's called the base and the legs and the vertex angle. The base is defined as the side which is not necessarily equal, and the legs are the equal sides. So if you think about the base as the other side and the legs are the equal sides, and the vertex angle is the angle between the legs, or between the equal sides. So if we just think about that for just a second, here we have a leg, here we have a leg, here we have a base, here we have the vertex angle. And these two angles are very important. These are called the base angles. So this angle here and this angle here are called the base angles. And let's think about the base angles. The key to the base angles are that they are the angle not between the two legs, but between a base and a leg. What's real important when we're doing a problem like this is that, so this is commonly the way the triangle is drawn. It doesn't necessarily matter how it's drawn. If these two sides are equal, let's think about this. Let's identify the base angle. The base angles, the vertex angle, the legs, and the base. And let's give these letters, let's call this C, R, and P. So pause the video now and fill these in. Okay, let's go through this. If we look at this, the base angles, well, these are the equal sides, so these two angles are the base angles. So we call the base angles angle C and angle R. The vertex angle is the angle in between the equal sides, so that's angle P. The legs are the equal sides, so that's CP and PR. Remember, when you're writing this, it doesn't matter the order. You could have just as easily said PC instead of CP. And the base is the side that's not necessarily equal. If these are the legs, then this is going to be the base, so that's CR. Leg, leg, base, base. Base angle, base angle, vertex angle. And now we have two theorems. The first theorem is called the Isosceles triangle theorem. We name it that because it was named after a guy named Isosceles. And it says simply this: the base angles of an isosceles triangle are congruent, or their measures are equal. And I actually think about this more in terms of a picture. If you have a triangle like this, where two sides are equal, that implies that the two base angles are equal. And that's the Isosceles triangle theorem. There's also the converse. The converse of the Isosceles triangle theorem is simply that if the base angles are equal, then it's isosceles. So you can change this to converse. And I actually like to draw it. It simply says this: if this angle and this angle are equal, then the sides opposite are equal. If two angles of a triangle are congruent, then, right, we always use the if-then idea. If the two angles of a triangle are congruent, then the sides opposite are congruent. And that's the end of part one. Now watch part two.